Okay, then this one, I think this one is actually say very close to what we want to do in our previous trials. Actually, we also try to list some cases how human make decisions initially and AI advice will affect it, and then we try to calculate measures for the appropriate reliance. But I think they defines in a better paradigm than we do. Yeah, so we can have a look at it. It's the same case that say we can explain it a bit. So first, it's a two-stage decision making. In the first stage, given the task, the crowd worker or humans will make decisions just on themselves, don't rely on AI systems and no other actuary information. In the second stage, the AI system will provide advice, maybe also sometimes explanations. Then the users will try to say, make their final decision based on their own understanding and AI advice. So here they try to show the effect of AI advice on their reliance patterns. That means whether AI advice changes their idea in the final decision making. So actually in the table, you see that in the four case, actually they show that when AI systems, I think this case, it means the initial advice is actually the same. I guess we can suppose it has a maybe multiple choice case, but the AI advice is actually the same with users. So actually, I think the top four case, they don't consider it as a reliance pattern. We also show similar concerns. So we only consider it as a reliance pattern when humans' initial decision is different from the AI advice, and then they show like say if user's initial decision is wrong while AI advice is correct, then it's positive AI reliance. But if after the AI advice users make a wrong decision, then it's still this means that users don't adopt AI advice, and then this errors they think it's up to the decision maker, so it's called negative self-reliance. With these patterns, then they try to define a proper reliance based on two dimensions. The first one is the relative positive AI reliance. That means when we should rely on AI, what proportion of positive AI reliance occupies. And then another one is relatively positive self-reliance. That means when AI system is incorrect, how often you rely on yourself and make correct decisions. Finally, actually they try to form it from these two dimensions. And you can see the diagram on the right side. Actually, they show that the appropriate reliance under their definition should be, say, on each case, they should positively rely on themselves when required, and they should positively rely on AI systems when AI systems is accurate. But it's actually a very ideal case. I think it's very hard to achieve. Yeah, but I think the two metrics make sense.
Did they do experiments? There was some experiments with actually use cases.
Let me see. I think I opened this one. Let me see. Yeah, there is some experiments with it, I think. Wait a moment. Do they have experiments? Yeah, they have some experiments about it. Yeah, but I didn't zoom into that. Maybe you can have a look at this paper.
Gaole, another look at this diagram, right? I've wondered the extent to which this consistently reflects the accuracy of the model, because right now, so the diagram and the way one can look at appropriate reliance is purely a function of self-reliance and the degree to which you rely on the AI system, right? So this is a completely reliance-based chart. But
Yeah.
but we do know that appropriate reliance is something that's shaped by the accuracy of the AI system, right? And in cases where you have an extremely bad AI system, then it's natural that, uh, well, it's not always the case, but one could expect that your self-reliance, a greater self-reliance, could be the way to appropriately rely on the AI system, right? So showing low reliance on the AI system is the appropriate way of relying on it. So would that be captured in this? Because I think in this two-dimensional way
I
of looking
think
at it,
it's captured. I think it's captured. Actually, you see that they have positive advice and negative advice. That means if AI make say advice correctly, then I think it's more we should more focus on the positive relative positive AI reliance. You can see the two cases. Yeah, so actually I think they cover this point.
relative positive self-reliance.
Can I say something?
Yeah.
I honestly think it's kind of different because here, from what I understood, I mean, I haven't read the paper, obviously, but probably I will. But from what I can understand here, it's just, it's not about whether the prediction the model gives is correct or incorrect, but whether the model tells you correct or incorrect as an output, basically. And they try to combine all these different combinations. So if the human says that the decision must be incorrect, the decision of the model is incorrect, but the model, so the output of the model is incorrect, but the model tells you that it's correct, and then the human decides that based on the model, they must change their prediction, their, let's say, their idea, their thoughts. Basically, this is classified as a positive advice because the human followed what the model is saying. Or at least this is what I understood from, let's say, just looking at the table. I don't think it's more about the outcome, whether the outcome is correct or incorrect, but the outcome is actually the word correct, or let's say at least.
No. I think that's so. This is one of the standard human AI decision-making ways of looking at it, right? So, correct, incorrect does mean whether the final outcome is correct or incorrect, right? But for the sake of this, you can treat both of them as equal, where the correct outcome is the label correct and the incorrect outcome is the label incorrect. But the notation is supposed to also hold for any human AI interaction where the final outcome is favorable versus unfavorable, right? So it's not just that the label is correct and the label is incorrect.
Also, does this, again, same thing, I might not fully understand it, but just looking at the metrics and the fact that it's effectively simple ratios, in a scenario where you're having a human and be advised consistently by an AI, does this take into account the possibility of streaks, I guess? So if an AI is consistently giving you the right advice over a long period of time, your reliance is going to skyrocket. And then all of a sudden, if it starts giving you wrong, you're still going to rely on that. Will that be captured within the ratio?
Actually, I think it's just on the overall, say, calculation. It doesn't account maybe the time series effects. But I think, say, there has been some research about, say, if we provide some correct advice at first, and then we try to provide the real case, that means decrease the accuracy to 50%, you will have large probability rely on it. I think also Wuzhou, they have some work as good first impression, also largely affect your trust on the AI systems. Yeah, I think there should be some work about it, but I think this measurement is not about this. It's mainly about maybe we have 10 tasks, 20 tasks. So overall, how good the participants appropriately rely on AI systems is on this. It doesn't consider the time series effects.